So, hello everybody. Sorry I can't be there in person, but I'll try and entertain you over the airwaves, over the internet. So, I'm going to argue that the verification feature needs an easier UVM, and I'll also give you something that you can go away and play with. So I'll start by motivating easier UVM, then tell you a little bit more about it. So it all starts with System Verilog, and we've all watched System Verilog grow to prominence over the last few years. System Verilog has now become a very, very successful design and verification language, and we all make good use of it. But many of us have sort of mixed emotions about System Verilog. It's a great language, but it's also very, very complex, and that can get in the way. And as you'll all be well aware, UVM has risen alongside System Verilog, UVM, the Universal Verification Methodology, as a way to help ensure best practice when using System Verilog for verification. So UVM gets actively supported by all the main simulation vendors. And we've watched UVM actually drive the successful implementations of System Verilog. So UVM has actually helped the vendors implement System Verilog consistently by having a single class library that they can all compete in the market to implement in the best possible way. And it's also given users increased confidence in adopting System Verilog. But it's not all good news, because UVM itself is very challenging. And we have lots and lots of conversations with users saying just how challenging it is to adopt UVM. So as we deliver training classes, training itself is a significant challenge. It requires a very significant upskilling to use System Verilog and UVM. So in our DDoS training portfolio, we spend 4 days teaching people System Verilog, and then another 4 days teaching people UVM. And at that stage, unfortunately, people are not necessarily ready to go off on project and start using System Verilog and UVM effectively, because there's still a lot to learn, a lot of detail to learn, a lot of experience to get under your belt before you're ready to use UVM effectively. So even after training, you may need to go on and look at using tools, getting some coaching from a specialist, or need further guidelines on how to use UVM. And then if we look at UVM itself, UVM is a very large, complex class library. So there's over 300 base classes in the UVM class library. The UVM documentation doesn't always answer all the questions you may have. And in UVM, there's lots and lots of ways of doing the same thing. I mean, I was running a UVM training class, a 4-day training class just last week. And at the end of the training class, I think people were still feeling fairly not brain dead about the whole thing, because there's just so much to learn. But we're having lots and lots of interesting discussions on just what the right way is to take all of these UVM features and use them. And when you look at people adopting UVM on projects, also you see a lot of debate, and sometimes unnecessary debate, about just what the right way is to use UVM, what the right features are to use, what the right way is to use them. And some of these debates are productive, because verification is difficult. There isn't just one right way of verification, of doing verification, and there's lots and lots of rooms for creativity. But some of the debates are not productive, because they become just pointless arguments about which feature you should use. So a few years ago now, back in 2011, we first of all introduced Easier UVM. And the first version of Easier UVM was intended right at the outset, when it first started. Easier UVM was intended just to make UVM a little easier to learn. So it was a reduced set of concepts all wrapped up in Easier UVM. And we've had some encouraging feedback from that, but people really want something more specific. So the second version of Easier UVM, the one that I'm talking about today, is built on the same set of principles, but it goes further than that. So now we've developed a specific set of coding guidelines, and that set of coding guidelines is quite prescriptive, and it gives one very specific way of using UVM. And also accompanying that, an automatic code generator to generate UVM code. And I should say right at the outset that what I'm describing here is not a commercial product that you can buy. It's freely available. The coding guidelines you can just download and use. The code generator is open source. So I'm not trying to promote a commercial product here. We don't particularly care at the end of the day exactly how you write your UVM code. This is simply our offering to the UVM community of a set of coding guidelines to get you started and an automatic code generator that you can build upon and customize for your own use if you want to. So the specific benefits that we see of having a set of coding guidelines for UVM and a coding generator is to help both individuals and project teams learn UVM, avoid the pitfalls of UVM, and become productive with UVM. So this code generator, or an early version of the code generator, has been used on industrial projects where it was found to save something like 6 weeks of effort at the early stages of a project, writing the first version of the UVM code by effectively having that generated automatically. It also helps project teams use UVM consistently by having a consistent set of naming conventions, a consistent way of using all of the features of UVM, a consistent way of putting together the UVM environment. And all of that can reduce the burden of supporting UVM code on a project once it gets established. What we've got in UVM is a code generator. So the code generator is simply a Perl script. It was originally based on a Perl script that Cadence donated to UVM World, so some of you may be familiar with that and used it already. And what we've done is to take that and heavily modify it. So it's made available under an Apache 2.0 open source license. You can grab the Perl script and do what you like with it. And it generates code that conforms to the Easier UVM coding guidelines. So let me say a little bit more about the coding guidelines and the code generator. The coding guidelines cover all the sorts of things that you would expect to see in coding guidelines or coding standards generally, only they do that in quite a prescriptive way. So the coding guidelines discuss how to organize your code at a very low level, naming conventions, the overall structure of the code, how to deal with clocks and timing, transactions, virtual sequences, connections to the blah, 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 all the things that you normally expect to see in UVM, right down to using the UVM register layer. So most of these coding guidelines are just common sense. There's no particular rocket science in there. But what we have done is to make choices for you. So we've made very specific choices about particular ways of doing things. And the purpose here wasn't that the choices we've made is necessarily the right choice, but we wanted to make a single choice so that people who are new to UVM can get started without having to figure out for themselves what the right way is of doing things. So if you have a look at these coding guidelines and you decide that you disagree with them and you want to do something in a different way, that's absolutely fine. You can modify the coding guidelines and do them in a different way. And if you want to come back to us and discuss with us and argue with us about what the best way is of doing things, that's fine as well. And if we all want to kick off a community, part of the UVM community, to actually forge together a set of coding guidelines that we can all agree on, that's great as well. So we're not particularly trying to say that everybody has to do things our way. In fact, we're not trying to say that at all. We're just offering to the community a set of coding guidelines that we can start using and then debate and improve on. So those coding guidelines will include the coding patterns that you will have seen if you actually read some of the Easier UVM papers from a few years back, describing how to use components, transactions, and sequences in a uniform way. Easier UVM also describes how to structure the overall verification environment, and there aren't any surprises here. So we have all the obvious building blocks of agents, sequences, virtual sequences, scoreboards, and so on, built up into creating a complete environment. We also go a little bit further and start to describe things like how to layer sequences and agents and how to describe layered protocols. Because as we start going deeper and deeper into UVM, then it becomes harder and harder to be prescriptive, because as you know, every project is different and every project has its own specific requirements. But nonetheless, as we get into some of the deeper aspects of the easier UVM coding guidelines, it starts looking less like a set of coding guidelines and more like notes for a training class. So certainly when people come on our training classes, we suggest that they go away and start using the easier UVM coding guidelines as a way to start getting deeper into UVM and become more productive with it. So the content of these guidelines helps reinforce formal training. There's also a bunch of examples that are bundled in with the coding guidelines, so specific examples that you can use to get started. Again, not rocket science, quite straightforward, but no doubt in quite a prescriptive way. Generator outputs the code for sequencers, drivers, monitors, coverage collectors, agents, environments, top-level environments to integrate lower-level environments, top-level tests, a top-level module to instantiate all the individual interfaces that are also generated automatically, and, getting more significant now, the register layer. So the code generator doesn't actually generate the register layer. You need a generator to generate the register layer, but then the code generator will integrate that in with the rest of the generated code, and also generate a complete set of sequences running on the individual agents, sequences running at the top level, and then virtual sequences to kick off all of the individual sequences. And by default, the generator generates a complete set of sequences to start getting all of the agents running. Now, of course, the agents at that point are just going to be generating random traffic. But what it does do is to give newbies to UVM an immediate way to get their environment up and running. So to get an environment up and running, all you need is a simple template file for each of your interfaces, describing the essential variables in each transaction, a template file describing how the top level is going to be connected together and how you're going to connect up the pins on your DUT. And then you push the button and get out a complete working environment. And of course, that's just the starting point. You're then going to start using that to fill in all the detail. So the generator is just generating all the initial boilerplate code and placeholders and effectively examples of what sequences are going to look like. So the boilerplate code that comes out is not particularly surprising. It just looks like UVM code. Within that boilerplate code, there are placeholders in which you can complete your own code. For example, to describe the code in the middle of the monitors and the drivers, the obvious bits of code that have to be user-defined. But what we've done is to actually have include directives in the middle of the generated code so that you can regenerate the code and include the same detailed code that you use to fill in the templates. And in simple cases, that might mean that you can get away with regenerating the code without having to rewrite all the code that you've modified. So the generated code can be used as a starting point for the actual production code in the verification environment. It can be also used to provide a set of examples so that you can get up and running very, very quickly. And this is pretty useful actually in production to convince managers that their teams actually do know what they're doing and are going to be able to make some progress. So pretty early on in the UVM project, you can have some code up and running and simulating. Even though actually you've still got a lot of work to do, it does actually show that you're making progress and can become productive with UVM. So all of this is available on the DoLOS website. I say it's available. It's going to be available very shortly. We're frantically working to get it released because we've been telling the world for a few months now how wonderful all of this stuff is. But we haven't actually released anything that's working yet. So hopefully within the next few days at this URL, we will actually have the coding guidelines and the code generator there for you to download. So watch this space. So if you want to know any more about anything we do with UVM, if you want to discuss the code generator with us or the coding guidelines, or if you're interested in any other DoLOS training classes, then do go to our website or contact me at DoLOS and we'll be glad to talk with you further. So that's all I've got to say for now, Mike.
Thank you, John. As always, very professional on time. So there's a bit more of applause for you.